In this presentation, we are going to learn manufacture of evaporated milk. We have already seen the manufacture of sweetened condensed milk, and we know the difference between sweetened condensed milk and evaporated milk. In sweetened condensed milk, we are adding sugar to enhance its shelf life, but in evaporated milk, to enhance its shelf life, after packing, we are sterilizing the milk. Sterilizing the concentrated milk. Right. Now we will see the principle. It involves evaporation and sterilization of evaporated milk obtained to provide better keeping quality of the product. And the steps involves receiving and selection of milk, clarification, cooling, storage, first standardization, preheating, evaporation, homogenization, then a cooling step, and pilot sterilization test is there. We'll see what is pilot sterilization test, and then the second or final standardization, packing, sterilization, and storage. These are the different steps. We'll see the flow chart. See, up to first standardization, it is one and the same. We have seen these steps for sweetened condensed milk, so here I am going to skip the initial steps. So these steps are, you see the steps that you write down the things. This is one and the same for sweetened condensed milk. Now, after homogenization, it is cooled and pilot sterilization test is done. Then comes second standardization and packing or canning. Then the cans are sterilized at 116 to 118 degrees Celsius for 15 minutes. Then it is cooled immediately, and the cooling time should not be more than 15 minutes. It is cooled to 27 to 32 degrees Celsius, followed by shaking and storage. Even during storage, the cans are shake. We have already seen these steps, so I am just skipping. But when you are asked to write manufacture of evaporated milk, you have to write everything, like all the steps. Okay, you should not write that it is same as sweetened condensed milk. You should write leading the quality from milk. That's why I included these slides here. I'll share the slides to you. So I'm just skipping. It is same as sweetened condensed milk. Okay. Platform test, you know it. Clarification, cooling, and storage. We use either centrifugal clarification, microfiltration, or bacterification for evaporated milk. In modern plants with a large capacity, either microfiltration or bacterification is done for milk intended for evaporated milk. Okay. Now the first standardization. Actually, there are two standardization. You know it. It is almost same as sweetened condensed milk. In sweetened condensed milk, we have 3 standardization steps. Here we have only 2. The first standardization, we are adjusting the ratio of fat and SNF, milk fat and SNF. And the desired ratio is 1:2.33. You just see the legal standards, then you will understand this thing. Okay. Now in the second, we adjust the final concentration of finished product. We are adjusting the total dry matter content. Okay. I am skipping these things. Now next step is forewarming or preheating. So you know the purpose, and milk is forewarmed to 115 to 118 degrees Celsius for no hold. You know the purpose. It is to kill the microorganisms and inactivate the enzyme, and to ensure uninterrupted restricted boiling in the vacuum pan, and heat stabilization of proteins. These are the purpose. Now comes evaporation or concentration. And mostly we are using multi-stage evaporators, and the density, sometimes density is checked. Now comes homogenization. So in sweetened condensed milk, homogenization is sometimes it is skipped, but in evaporated milk, homogenization is a must. It has to be done, and it is done. So it is done to obtain a uniform fat emulsion and to reduce the fat separation to a minimum during storage. And it is done in two stages. 2000 psi in the first stage and 500 psi in the second stage. Okay. And it is done at normally at 49 degrees Celsius, because it is the temperature at which product is drawn from the last effect of the evaporator. Then after homogenization, evaporated milk is cooled to 7 degrees Celsius. If it is normally in batch sterilizers, we have to keep the sterilized milk and we have to go for pilot sterilization test. It will take some time, so we will have to store the evaporated milk sometime before proceeding for sterilization. So there are some delay in packing. So what we are doing, we are cooling the evaporated milk normally to 5 degrees Celsius and held in large storage tank. Okay. Now comes the second standardization. So same it is similar to third standardization in sweetened condensed milk. Normally what they do, they will over condense the milk to facilitate standardization. Okay. And here we have to add some stabilizing salts, because when you concentrate milk, its heat stability is affected. When you sterilize concentrated milk, normal concentrated milk, it is most probably there are chances of coagulation. So stabilizing salt may also be added at this point if pilot sterilization test indicates such a need. Okay, we'll come to that. What is pilot sterilization? So it is a test carried out in laboratory. During this test, varying concentration of stabilizing salt or agents are added to samples which are subjected to sterilization, and their stability is examined. Okay. On the basis of the test, the quantity of stabilizing salt to be added to milk is determined, and the purpose is to determine the amount of chemical stabilizer, and normally we add phosphates or citrates. Okay, trisodium citrate or disodium phosphate. There are different many stabilizing salts, and what is the principle? What happens, no? And we'll discuss the heat stability. It is a big topic. We'll discuss the heat stability of concentrated milk in another class. But in short, what happens, no? When milk is concentrated, the calcium affects the stability of milk protein, and the milk when you sterilize it, it will coagulate. Okay, so this stabilizing salts like carbonates or bicarbonates or citrates or phosphates. They'll combine or they'll hold the calcium, and being bound by these anions, calcium from milk cannot adversely affect the protein system. Okay. Now what they do, they'll take some concentrated milk from the storage tank, and they'll add different quantities of stabilizer salts, diluted stabilizer salt, into 100 ml of evaporated milk. They'll take evaporated milk in 100 ml bottles. Okay. Say there will be 10 bottles of concentrated milk. To each, there is a table. I'll show you. Can you see this? Hope you can see this, isn't it? So there are different cans, and into here it is given 170 gram. It depends on your can size, and they'll add the stabilizer solution plus water. The quantity of the solution will be same. Like if you're adding 10 ml, the concentration will vary. Concentration of stabilizer salt will vary. So you are adding different concentration to different cans. Then they will sterilize the sample. This different cans are sterilized in a lab sterilizer, pilot sterilizer. Kind of autoclave. Okay, you imagine autoclaving these cans, filled cans. So for every batch they have to do this pilot sterilization. So these sealed, these cans are filled, and stabilizing salts are added at different concentration. Then they are sterilized. They are sealed and sterilized in an autoclave. And time temperature combination should be the same as that of your final sterilization, that is 116 to 118 degrees Celsius for 15 minutes. Then it is the bottles are, after sterilization, the bottles are immediately cooled to 24 degrees Celsius with the help of airflow. Actually, in pilot sterilizer, the pilot sterilizer is same as that of your original sterilizer. Okay. Now examine the bottle contents for smoothness and color, and test for viscosity. And they'll check if there is any clot or anything, and select the bottle whose contents show a desirable body and smooth texture. Okay. Then they will find out the concentration of stabilizing salt added to that bottle, and that is your concentration to be added to your original concentrated milk. You kept, you remember you cooled and kept that milk in a large storage tank at 5 degrees Celsius. So you found out the concentration of stabilizer salt for that batch of concentrated milk. Now, based on the correction corresponding to the pilot test, calculate the total quantity of stabilizer required for the bulk of the evaporated milk to be prepared. Just add enough water to for complete solution of the stabilizer in a vessel. That is, you should not add the salt in dry form. You have to add it in the form of solution. In a bucket, you just mix with a small quantity of water and add the mixture to the evaporated milk in the storage tank, ensuring thorough mixing during addition and for several hours after its solution. So for 2-3 hours it has to be mixed properly for uniform mixing, because this evaporated milk tank will be more than, and the capacity will be like 1 lakh liters or so. So it will take time to mix it properly. And for subsequent batches of evaporated milk, add a portion of the required amount of stabilizer determined by previous day's experience to the entire fluid milk at the forewarmer itself, and then complete the correction by adding the remainder to the evaporated milk in the storage tank. So for subsequent batches, actually the amount of stabilizer normally changes with season. Okay, many when I discuss heat stability, I'll tell you what are the different factors affecting the heat stability of milk. Season is a very important reason, or the factor affecting heat stability of milk. So in a season, the amount of stabilizer will be almost similar, so you can have an idea like this much quantity will be required. So you can add a part of it in the forewarmer itself, during forewarming itself. Then the balance will be added to the storage tank after pilot sterilization test. Okay, now you go for packing. Normally packing or canning, you can call it as canning also. Packaging in cans is common, but some manufacturers, especially the evaporated milk intended for use in coffee, is usually packed in bottles, glass bottles that are closed in with a crown cork or a screw cap. The can should meet all sanitary standards. Then evaporated milk container must withstand the pressure changes in the process of sterilization. Okay, otherwise it will flip, or the shape will change. Its seal must be absolutely airtight and it must be strong, because we are sterilizing the cans, and cans should be filled as nearly full as possible. Okay, and the temperature of filling should be is very important. It should not be high, because if the temperature is very high, the milk will foam, and there will be air inside the can, which will hinder with sterilization. If you because if there is air inside the can, why I in the last slide I told you the can should be filled as nearly as full, because if there is air, when you heat it, what will happen? It will expand, and it will the cans will bulge. Okay, and if the temperature should be around 5 degrees Celsius temperature of filling. Why? Because if it is below or excessively low temperature, what will happen? It will increase the tendency of flapping. Flapping means I am stopping here, and I will continue in the next video. Okay, thank you.